This is topic 5, lesson 6, two-digit quotients. So in this video, we're going to look at how do you find two-digit quotients using a two-digit divisor. So really, this is the same basic process as one-digit quotients um, or the two-digit quotients that we've done with one-digit divisors, and this is all the same process. All this division is just that it gets a little bit more complicated when you have two-digit quotients. So we've kind of eased you in by having you estimate, then do multiples of 10, and then do ones that have a one-digit quotient. And now we're going to kind of go up to a two-digit quotient. So we're going to start with 298 divided by 16. And our first step, you should know at this point, is to estimate. So we're going to take this and we're going to think to ourselves, what can I round to this? So I'm going to use my 16. I'm going to leave, or I could actually change my 16 to a 20. And so I've got 2. So I want to round that. Basically, I want to round it to any even number. I could round it to 30. So round this to 300. And then our basic factor would be 30 divided by 2 equals 15. And then 1 0 minus 1 0 would be no zeros. So I would estimate this to be, my answer is going to be somewhere near 15, although it's not going to be, you can tell from that, we're dividing up into a lot more places. So it's not going to be quite as accurate as we want. But still, we know it's a two-digit quotient, and we know that we know that it's going to be somewhere near 15. Okay, so our first step is obviously going to be to set up our problem. 298 divided by 16. And since I'm pretty sure this is going to be a two-digit quotient, I know I'm going to start in the tens place. And so how many times does 16 go into 29? 16 goes into 29 one time, because there's 116, because 2 16s is 32. That would be too high. Remember, we talked about this in the last video. If the number is too low, if you get when you subtract, if you get a larger number, you know that the number is too low. But if you can't subtract, so if I'd done 2 times 16 and got 32 here, and I couldn't subtract, then I'd know this number was too high. Okay, so 1 times 16 is 16. 9 minus 6 is 3. 2 minus 1 is 1. And now we're going to check, right? So we divided, then we multiplied, then we subtracted, and now we're going to check. 13 is lower than 6. We're okay. So now we're going to bring down the 8, because I need to have a number over each number in the dividend. And 138. So this is where it gets a little bit trickier, right? We have to think to ourselves, how many 16s do you think there are in 138? And this is probably one of those things. And if you're sitting there kind of scratching your head and you're like, well, I don't know off the top of my head, well, that's fine. Nobody's going to know off the top of their head. So we're going to think to ourselves, okay, well, if I change this to 160, that would be 10, but that's a lot. So, I'm going to try 9. 144 is too high. So I'm going to try 8. 128. And sure enough, that would work. Again, this is going to be a little bit of test and check. You're not going to necessarily, don't get frustrated if the first number you try doesn't work. It's too high or it's too low, because that's pretty typical when you get to these, when you start dividing a two-digit number by a three-digit number, that's when you start to get into this, you don't know your 16 tables. Nobody does. So you don't know that 16 times 8 is 128 off the top of your head. So you're going to have to kind of do a little bit of guess and check with this and think what makes sense. And sometimes what you can do is you can start at 5, and then that's a good midway point, and think, does it have to be higher or lower? So anyway, so I'm going to put an 8 here, and we're going to put 128. Subtract. Right, those are both subtractions. 10, and then I'm going to check, and sure enough, 10 is lower than 16. Then I'm going to go through, and I'm actually going to check my problem. So I'm going to do 18 times 16. Unfortunately, these checks get more difficult. They're a little bit more work, but in some ways, they're also more important. So 8 times 6 is 8, 4, 10, put 0 in, right? 8, 1, add 8, 8, 1, I have 2, oops, because 1 plus 1 is 2, and I'm going to add in my remainder. I get 298, and sure enough, so that's the right answer. So we could express this as 18 remainder 10. We'd express this as 18 and 10/16. We could also simplify this, which we haven't talked about yet, but we will be talking about simplifying fractions. So you could simplify this as 18 and 5/8. So any of those would work. You could also find out what 5/8 is as a decimal. 5/8 it does work out as a decimal, and you could express this as is that way as well. I don't want to confuse people, but you could do your division, 5 divided by 8, and find out what decimal that is, and you could do that. You could do that, and that would also be right. It is, if you divide 5 divided by 8, you get, hold on. It's 0.625. So this could also be 18.625. So any of those answers would be correct. I think you're going to find that these three answers as you go forward are going to be the ones that the teachers are going to ask for. They're kind of going to get away from this remainder 10 thing here. I want to do one more for you because this one's a little bit different. And so I'm going to stop doing my estimating. I'm going to round my 47 to 45. I'm going to change this to 90. Because I know that 90 divided by 45 is 2. And then 1 0 would be 20. So I know I'm going to have something close to 20 is going to be my answer. 47 goes into to 98. So well, I'm going to think to myself, well, I know there are two 45s and 90. I wonder. So I'm going to draw a little line here to give myself some space. 47 times 2, I get 94. So that's good. So I'm going to put 2 here, 94, 4, and I'm going to bring down the 5. So 4 was lower than 47, so that was okay. Now, 45 is lower, right? So than 47. So I can't do I can't divide 47 into 50. There's less than 147 and 45, right? So what I'm going to do is, there's a couple different ways of handling this, but for today, what we're going to do is we're going to put a 0 here, right? So this would be 20, remainder 45. Now, I knew I had to have a 2-digit answer. I knew I had to have a number over the 8 and over the 5 because it was a 2-digit answer. So when I just had a 2 there, it wouldn't have worked. The other thing too is if I did this out and I tried to check, did 2 times 47 plus 4 or 45, I wouldn't have got the right answer. Nothing even close. So I know 2 times 47 is 94. So 20 times 97 would be 940 plus 45 would be 985. So there's my check. So I know I'm right. But that's very important that when you're doing this, you have to have a number over every number in the dividend, okay? So that from where you start, I started in the tens place, that means that my number was going to be a number in the tens. It's going to have something over the tens and over the ones. Okay, why don't you try it? You try 292 divided by 23. Okay, how do we do? So let's start by doing our estimation. And I'm going to rewrite the problem up here. And I'm actually just going to leave my 23 to 23 and make this 230. So 23 divided by 23 is 1, and the 10. So I know there's a good chance, and I know this is probably a low estimate, so I know that this is going to be a 2-digit quotient because it's going to be somewhere around 10, probably a little bit bigger than 10. So 292 divided by 23. So 23 goes into 29 one time. So we multiplied. Now we're going to subtract. Now we're going to bring down the 2, 62. And now I have to think to myself, how many 23s are there in 62? And so I have to think, well, 123 is 23. That would be way too low. 2 23s is 46. 3 23s is 69. So 3 23s is too high. 2 23s is just right. So 1 23 would be too low. 3 would be too high. 2 is just right. Let's see. So we're going to put 82 here for 46. So I would have 12 remainder 16, which would be 12 remainder 16, or 12 and 16 23rds. And I have a feeling if you divide 16 by 23, you're going to get a big long decimal. But so that's how you divide with two-digit divisors with a two-digit quotient. Thank you for listening.